the final thing to look at in inverse trig is this idea of general solutions. Normally when we solve trig equations, we say, oh, but I only want solutions between A and B. And usually that's 0 and 360 or 0 and 2 pi, depending on whether we're working in degrees or radians. But of course there are an infinite number of solutions if we were not to have a restriction, because the domain of our curves are all real x and it just keeps repeating all the way along. So how do we write a generalized formula? So the general solution for those trig equations. So what we're going to do is just have a look at creating the general solutions, see where they come from. So if it was a sine one, so we get down to sine theta equals some ratio. Well, it all depends whether x is greater than 0. Because remember, when we're solving a trig equation, the first thing we ask ourselves is which quadrants are we in? And to solve that, we need to know whether it's negative or positive. So let's look at the case where the ratio is positive. If the ratio is positive, then I know the acute angle would be whatever the inverse sine of x is. Okay? So remember, your calculator with the sine will give out an acute angle for a positive ratio. So in the first quadrant, we know it's inverse sine x. The other quadrant it would be in would be the second quadrant, but it would be pi minus the acute angle. So my solution would be inverse sine of x, or pi minus the inverse sine of x. That's if x is positive. Let's have a look, see what happens when it's negative. So if it's negative, now the acute angle is now the inverse sine of negative x. Because we're saying x is now negative. And the acute angle, the ratio needs to be a positive number. So therefore it's the inverse sine of negative x that we're finding. And we would be in the third quadrant or the fourth quadrant. So our third quadrant answer would become pi plus the inverse sine of negative x, or 2 pi minus the inverse sine of negative x. All right, but we've got a rule for inverse sine of negative x. We know inverse sine is an odd function. So inverse sine of negative x is the same as the negative of inverse sine x. So I could rewrite this to be pi minus the inverse sine of x, which actually, you'll notice, is the same answer as when it was positive. Or the other one would become 2 pi plus the inverse sine of x, which actually is the same as the first one. All that we've done is gone around the circle the whole time. So it actually does not matter whether it's positive or negative, we get the same answer. So inverse sine x, pi minus inverse sine x, then 2 pi plus inverse sine x. The next answer would be, very good, 3 pi minus inverse sine of x. Remember, we just keep adding 360 degrees or 2 pi to each answer. So the next one would be 3 pi minus inverse sine of x. Then the next one would be 4 pi plus the inverse sine of x. Next one would be then, okay, we're starting to get the pattern. So I could generalize that. It's simply going to be, if we got sine theta is equal to x, we can say x is multiples of pi plus minus 1 to the power of k, because that will now alternate between plus minus the inverse sine of x. And k, of course, has to be a whole number. Right? So when k is an even number, then negative 1 to the power would become plus. And when k is an odd number, it would be minus. But that would generate every possible solution. All right. Let's see what happens with cos. We'll approach it the same way. If x is positive, okay, the acute angle will be the inverse cos of x. We're in the first quadrant or the fourth quadrant this time. So I've got inverse cos of x, or 2 pi minus the inverse cos of x. All right, but what about if x is negative? If x is negative, now the acute angle would be the inverse cos of negative x, because again, to find the acute angle, the ratio needs to be positive. We'd be in the second quadrant or the third quadrant. So in the second quadrant, I would be pi minus the inverse cos of minus x, or pi plus the inverse cos of minus x. What was our relationship for inverse cos of minus x was equal to Who remembers? Hang on, I think I heard it somewhere. Pi minus, okay. So yeah, it would be pi minus the inverse cos of x. So this one would become pi minus inverse cos of x, which is inverse cos of x, same as our first answer over here. And the second one would become pi plus pi minus inverse cos of x, 2 pi minus inverse cos of x, same as the second answer. So again, does not matter whether x is positive or negative, we get the same answer. So the first answer was inverse cos of x. The next answer was 2 pi minus the inverse cos of x. What's the next solution? So the solution 1, inverse cos of x. Solution 2, 2 pi minus inverse cos of x. Solution 3, 2 pi plus the inverse cos of x. Add 2 pi to the first solution. Solution 4, 4 pi minus the inverse cos of x. Solution 5, 4 pi plus the inverse cos of x. Solution 6, 6 pi minus. Solution 7, 6 pi plus. Now we're starting to pick up on the pattern. Next solution, 8 pi minus. Next solution. All right, so our pattern basically then is multiples of 2 pi plus or minus the inverse cos of x. Let's see if we can pick up on the tan one a bit quicker. We'll see. If tan is positive, so once again the acute angle would be the inverse tan of x, first quadrant and third quadrant for tan. So we have inverse tan of x or pi plus inverse tan of x. Okay, let's have a look if x is negative. Now if x is negative, the acute angle, inverse tan of negative x, because we need a positive ratio to get the acute angle. That's the second quadrant and the fourth quadrant. So our first answer will be pi minus the inverse tan of minus x. Then our next answer, 2 pi minus the inverse tan of minus x. What was the rule for inverse tan minus x?
Minus inverse tan.
Right, because it was an odd function. So it's going to be minus inverse tan of x. So we get pi plus the inverse tan of x, same as the second one here. 2 pi plus the inverse tan of x. Well, effectively, that's the next solution when you add 2 pi into this. So again, we get the same solutions. So first solution, inverse tan of x. Second solution, pi plus inverse tan of x. Next solution, 2 pi plus inverse tan of x. Next solution, 3 pi plus inverse tan of x. Next solution, and so on, and so on, and so on. So for this one, I don't need, like I did with the sine one, I don't need that negative 1 to the power of k because it's always plus. So this one is pi k plus inverse tan of x. Okay. All right, let's see how we use them. Sine theta is root 3 on 2. Well, okay. So we generalise it. Sine was pi k plus, but we needed to alternate, plus minus, plus minus. So I've got the minus 1 to the power of k, inverse sine root 3 on 2. Now if we can work out the actual answer for inverse sine, we do. And that is one of our exact values. Inverse sine root 3 on 2, pi on 3. So there's our answer, pi k plus minus 1 to the power of k, pi on 3. Make sure somewhere in your solution you have specified though, the k is an integer. Now, I could use that now to generate solutions. So what if I now said, oh, hang on, but actually I only want answers between 0 and 2 pi. I could go back and solve it as we would traditionally. But now that I've got a formula, I'm not going to do that because I can just substitute numbers in. If I substitute 0 in for k, I'll get minus 1 to the power of 0, which is 1, so pi on 3. If k is equal to 1, I'll get pi minus pi on 3, which is 2 pi on 3. If k is equal to 2, I'll get 2 pi plus, oh well, no need to go any further because we only want between 0 and 2 pi. So as soon as I say 2 pi plus, I know I'm outside. So there's my answers, pi on 3, 2 pi on 3. Let's try it, cos 1. Cos theta equals minus 1 on root 2. So 2 pi k plus or minus the inverse cos of minus 1 on root 2. Minus 1 on root 2. All right, I could say inverse cos of minus 1 on root 2 is pi minus, and do it that way. That's going to get a little bit messy because of the plus or minus. So I might actually work out the inverse cos of minus 1 on root 2. Now remember, inverse cos gives us answers where? 0 to pi. So in this case, I will get what type of angle? Got to be an obtuse one. So it's the obtuse angle. Well, 1 on root 2 would be inverse cos of pi on 4 would be the acute angle. So the obtuse angle, 3 pi on 4. So we got 2 pi k plus or minus 3 pi on 4 for that particular one. Again, if I wanted to generate the solutions, I could start at naught and I'll get plus or minus 3 pi on 4. Well, I don't want the minus one, that's outside, but I'll take the plus one. So there's the plus 3 pi on 4. If k is 1, I'll get 2 pi plus or minus. Well, in this case, I don't want the plus one, but I'll take the minus one. And there's my two answers, 3 pi on 4, 5 pi on 4. All right, let's complete the set. Let's do a tan one. So 1 on root 3. Inverse tan of 1 on root 3. Exact value again. 1 on root 3. Pi on 6 for that one. So there we go. Pi k plus pi on 6, where k is an integer. If I wanted to find solutions, I'll start at naught. I'll just get pi on 6. Sub in 1, I'll get pi plus pi on 6. Sub in 2, I'll get 2 pi plus. Okay, I've gone too far, so I won't do that one. Pi on 6, 7 pi on 6. Now, I'm not suggesting you would solve trig equations this way. However, if we do have the general solution, that's when I might use it to save myself going back to the start. Ooh. Sine theta is equal to the sine of 5 pi on 7. Again, the temptation is to say, oh, theta is 5 pi on 7. But that, of course, is just one possibility. Oh, look, here's another example. Sine theta equals sine 5 pi on 7. Of course, the temptation is to just say theta is 5 pi on 7, but we wouldn't be foolish enough to do that. Oh, no, no, no. Because that would just be one solution. We want all the solutions, so let's use our general formula. Here we go. Pi k plus minus 1 to the power of k, inverse sine, the sine 5 pi on 7. Now, 5 pi on 7, would that be acute or obtuse? Wow, that was very quick. Well done. Okay, so it's obtuse. In the second quadrant, is sine positive or negative? Yeah, only a fool would think it would be negative. How foolish. All right, so, of course, that therefore means we want the equivalent positive acute angle. So 5 pi on 7 is the obtuse angle, the matching acute angle that goes... 2 pi on 7. Very swift. Well done. So this will become pi k plus minus 1 to the power of k, 2 pi on 7. And I won't hear of any other answer. All right. Let's move to the next. Oh, cos. This time I might get it right. Just the fact that it's 2x doesn't matter. I mean, we'll solve for 2x and then just divide by 2. So, inverse cos, that was 2 pi k plus or minus the inverse cos of the cos of pi on 9. Pi on 9, acute or obtuse? Oh, thank God for that. So we can just cancel. That one will be pi on 9. So that's what 2x is, though. So to get x, then divide by 2. 1f will play with the general solutions. So there we go.